how to make something colder than ice by just using ice. Pure water freezes at 0 degrees Celsius. So that means if you have a mixture of ice water like I have here, it's always going to be at the temperature of 0 degrees Celsius, not higher or lower. For example, if I heat it up a little bit, I'm not actually going to raise the temperature, but what's going to happen is I'm just going to melt the ice. Also, if I cool it down anymore, I'm just going to turn some of that liquid water into ice. Okay, but now let's take some of this ice water without ice in it. So we're at 1.4 degrees Celsius, so the water has warmed up a little bit, but now watch what happens when we put calcium chloride in it. (1.5 degrees, 1.6, so 3.5 degrees Celsius right now. So by putting in the calcium chloride, we heated up our water. That's because when calcium chloride dissolves in water, it's exothermic. So now let's do this again, except this time let's leave some ice in here. So the temperature is going down, understandably, because we just added ice, but we wouldn't expect it to get colder than the original solution of ice here. Okay, so look at this, negative 1.2 degrees Celsius. So somehow just by adding ice into water of a solution of calcium chloride, I got a colder temperature than either of them were to start with. In fact, you can even get it so cold if you use a lot of calcium chloride, you can actually get ice to form just from the water that condensed from the air on the outside of the glass. The reason has to do with the long-time notion that salt melts ice. Well, the thing is, salt doesn't really melt ice at all. It dissolves it. And there's a big difference between the two. For example, if I just took this beaker of ice water and I heated it up, it wouldn't change temperature until all of the ice had melted. But if I put calcium chloride in here, I could dissolve the ice and it would turn into liquid water, but I wouldn't be adding any heat. And in fact, in doing that, I would actually decrease the temperature. Now, the reason that salt water dissolves ice is that the ice actually has a higher concentration of water than the salt water around it. So it wants to push some of the pure water into the less pure water to try to make it equilibrate together. What that means is that whenever you have any contaminant in liquid water around ice, the ice is going to want to dissolve into that mixture. And when it dissolves into it, it absorbs heat, and so it lowers the temperature. So that means that we don't need calcium chloride to do this. We actually need anything. Watch what happens when I add colder than it was to start with. So somehow, just by adding soda to the ice water, it made the ice water colder than freezing. That's because when the solid ice dissolves into the liquid soda, it's actually an endothermic process, so it's absorbing heat and lowers the whole temperature. So let's say that there's ice on your driveway outside. Well, the ice that's out there isn't actually solid ice. On the surface of all of the ice is liquid water. And that liquid water is going to get some of that calcium chloride in it, and the calcium chloride is going to dissolve into it. So it's going to dissolve solid ice into liquid water, and that's an endothermic process, and so it's going to decrease the temperature. So overall, it just looks like you threw some calcium chloride pellets out there and you melted the ice on your driveway. But what you mean is that you ended up with less solid ice. So calcium chloride melts ice faster because it also is exothermic when it dissolves in, and it also can dissolve ice better. So when you put sodium chloride in water, it will decrease the temperature, calcium chloride will increase in it. And thanks again for watching another episode of the Action Lab. I hope you enjoyed it, and I'll see you next time.